Welcome to the Databricks Skill Builder series. We're glad you're here. Mainly, we'll be focusing on how you use Graphframes. And if you'd like to follow along, please start up a cluster with a ML runtime of 11.0 or higher. And hopefully you have your GitHub credentials already set up to access GitHub, and you can pull in the code from there. So I'm going to start with just letting you know there is a blog and a solution accelerator that's associated with this presentation, which actually means I stole this from them, and I iterated it on a little bit so that it would be more appropriate for a presentation. And here is our GitHub. Let me drop the link for this in the chat so you can access that. So all you do to utilize this is go ahead and take the code from here, or from here where it says code, you copy this link and put it over into Databricks. So when you come over here into your Databricks instance in repos, you can see I've pulled in, and this is my version of the anti-money laundering solution accelerator here. And you just go to add a repo. That's where you put the link in. It'll automatically select GitHub for you, and then you can name it whatever you'd like. And then you do create repo, and it'll pull all the code for this session into Databricks for you. Any questions? Is anybody having trouble getting set up? Do you want me to give you a few minutes? Feel free to drop stuff in the chat or the Q&A while we're just getting set up. Happy to help, or raise your hand and we can unmute you. Just want to make sure that everybody has a chance to get set up if they want to follow along. Okay, how about this? Raise your hand if you want me to stop and hang on a second. Nobody. Everybody's ready. Okay, sounds good. I'm going to go ahead and jump into the slides then. Okay, so how does money laundering work? What is it? I think that's important to have a little bit of a basis before we get started. That is not my expertise, so I have this wonderful YouTube video for everybody to watch just to get us started.
Welcome to the e-learning module of anti-money laundering and combating terrorist financing. In this module, you will learn what is money laundering, different sources of dirty money, and the various stages of money laundering. Now, let's see, what is money laundering? Money laundering is the process whereby criminals attempt to hide and disguise the true origin and ownership of the proceeds of their criminal activities, thereby avoiding prosecution, conviction, and confiscation of the criminal funds. In simple words, it is a process through which dirty money is converted into clean money. Now that we know the definition of money laundering, it is important to know the sources of dirty money. In this category, we have drug trafficking, human trafficking, criminal offenses, gambling, smuggling, and many more. Other sources of dirty money are bribe, fraud, tax evasion, and kidnapping. Let's look at the 3 stages of money laundering. First stage is the placement stage, the second is layering, and the third is integration. Now, let's look at each of these stages in detail. Placement stage. Here, the cash generated from criminal activities is converted into monetary instruments such as money orders, traveler's checks, or even the cash is deposited into accounts of the financial institutions and even banks. This is the very initial stage where the cash is getting placed into the legal financial system. Layering. The funds are transferred or moved into other accounts or other financial institutions to further separate the money from its criminal origin. Integration stage. The last stage is the integration stage, wherein the funds are reintroduced into the system or into the economy. These funds are then used to purchase legitimate assets or to fund other criminal activities which come under legitimate business. Ultimately, this is done to show that the money used to buy these assets is indeed from a legal source. Now, let's summarize the process of money laundering. You have the first stage of placement, where you can see the money is getting placed into various bank accounts or financial institutions. Then this money gets layered through wire transfers, bank deposits, offshore bank accounts, and even on trade basis. And from there, the next stage is into the integration stage, wherein the money is used to purchase luxury assets. That could also be for financial investment, commercial, and industrial investment. So, this is a typical money laundering process.
All right. Hopefully that wasn't too painful to watch.
Welcome to the e-learning
Nope,
module of
nope, not
anti-money
okay. No,
laundering.
thank you. Okay, so as I mentioned earlier, we'll be talking a little bit about graph theory, specifically using a library called Graphframes. So I just wanted to get clear on some graph terminology before we get started. A vertex is a node or a green dot on the screen here. And does anybody know what the degree of a vertex is? This is going to be heavily participation oriented, so I'm going to need you all to be brave and talk to me. Or it's going to be very painful for all of us. Anybody know what the degree of a node is or a vertex in a graph? If you raise your hand, I can unmute you. Or you can drop it in the chat if you're shy. All right. So that's okay. So what a degree of a vertex is a the number of edges that are connected to it. So you have in the top up here, you've got several that are out by themselves. Those would have a degree of 1. If they have more edges, of course, they have a higher degree. The little square to the left, top left, would be considered a connected component. So this is a subgraph or a component of a graph that's all connected together. And in this case, each of them have a degree of 2. Each node of the graph has a degree of 2, and it's all connected together. So in this total graph here on the screen, we have 3 different subgraphs that are components, connected components. And so we'll use that concept as we're going through to talk about the network of identities and whatnot for possible money laundering. Okay, so now we're done with slides. Let's hop over into, oh, I got too many things going here. Here we go. Into our notebook. So the first place we're going to start is making sure that we've run the README. So we now have our data or our code pulled in into our repo. And the first thing you want to do is run your README. So you can just attach it to whatever cluster you have already spun up. And then you're going to run that. And what it's going to do is make sure that all of the libraries that are necessary for this are installed, as well as set up a job. So you'll notice that there's a whole bunch of JSON here. And then down at the bottom, since I've already run mine, you can see that it's pointed to a runner. So what that means is that for this in the RunMe, we've actually set up a workflow already. So by running the RunMe, you can go into your workflow and check your workflow for all the different tasks. So you can see that this job has been created, and what it does is it runs each notebook in sequential order. And it already has set up on the right-hand side. You can see that there are already tags added to it, as well as a compute cluster that's set up to be shared between the different tasks. So that'll make it a little bit faster. The compute doesn't have to stand up and go back down in between the different tasks within your workflow. So you'll be able to, it'll spin up, run each of the different tasks, and then spin back down. I get to add email notifications if I would like, or change the permissions on it. Sorry, I have a cat, and I'm at my boyfriend's house, and the cat is making noise, so apologize for that. And as we continue to walk through this, we can look at the runs. I actually haven't run this yet, so I don't have any runs. You won't have any runs in here either, as you're just starting to set it up. But it is a really good example of how you can automatically create your workflows. If you wanted to create jobs that are more automated in the sense of, instead of using the UI and clicking through it, you can actually complete that. Oh, yes. Thank you, Haley. I believe the cat is he's into money laundering, which is why he's dumping things off the kitchen table. Okay, so now that we have that set up, we understand that there is a workflow that's going to run each of the notebooks in sequence for us. We can go back in here and take a look. So the first piece that's set up here is the 00 notebook. This is really just for context information. It gives you links to the Databricks GitHub where code is located. We also have the link here to the blog. So if you wanted to see how this is explained in the blog, you can click there and take a look at that. I'm going to be sending both those links out with the follow-up email with the recording, and discusses a little bit here about how kind of all this fits together in terms of Delta. Here's the libraries that we'll be using, so you have access to knowing which ones they are, as well as the documentation for those. But today we're going to spend our time in the first notebook, which is network analysis. Okay, so we're going to start with the graph patterns for looking for different IDs. But let's so what's up here, this is basically a description. I'm not going to read that to you. We're going to be using Graphframes to help solve this. You can see we're starting with the config. So I would suggest, because some of this code takes a while to run, be sure to hit that run all at the top as soon as you have attached your cluster to the notebook, so that you can have it completely run as you go through. And so here, we should take a look at the config real quick, so you can just see what that's doing. So we'll jump in here. So again, it's installing any sort of extra things that haven't been installed yet. It's using a specific version so that everything stays compatible. And then you can tell that we've got the files just being set up. So this is meant to make sure that we're putting notebooks into our own user directory, creating the database as we need it, a config for us to put all of the different pieces into the database, and just setting everything up. You can see that there's an ML flow experiment that's tracking this as we go. And that's pretty much it for the config file. So we'll jump back into the network analysis. Okay, so our config has been run. We have all of the libraries installed. We have our ML flow experiment running. So let's talk about entity resolution and synthetic identities. Basically, you can think of this as individuals who are using different names. So they may try to be Bob and Krishna and Jessica all at the same time. And so they use the same address or they use the same phone number or other information so that the information flow from the banks is still being sent to them, but they are a different person, essentially. And so if you're just sharing an address with another person, that's not really of high concern, right? Low concern, you probably just live with another individual. But if there are identities that are sharing lots of information, so the phone number and the email address and the address is all the same, that's more of concern. And then of course, the most high risk would be a sharing of things like a social security number. Okay. So a lot of times we want to do our analysis using SQL. This is actually a lot easier to do with Graphframes, which is kind of the point of discussing SQL here. Is here's what our data looks like. We can use SQL to easily display what our database of transactions looks like. This is actually data that's used later. We won't use this in the synthetic identities section. And then this is just really kind of showing you what the data looks like in terms of the database of entities. So this is coming from, we have a whole database of entities that's connected up to different transactions. And here you can see that there are some shared addresses as well as shared emails. This is specifically pulling those that have shared emails, just to make it easier to kind of see what we're looking for. Okay, so Graphframes. Graphframes actually make analyzing our data a lot easier because our SQL statements can get super complex to try to accomplish what you can with Graphframes. And so we go ahead and import the Graphframes here. And the first thing we're going to do is build our graph. So if we go back up real quick and take a look here, we have Christopher McBride. He has an abrown@gmail.com email address and lives at a certain address. The name is not as important really as tracking the entity ID. We can always reassociate those as we need to and whatnot. So any idea of like what could possibly be an issue here when we're trying to look at like how clean this data is, or something we would be concerned with if we were actually doing this in practice to try to look for synthetic identities? I can tell you that the phone number doesn't seem to be formatted very well, which can be very difficult. And generally addresses are not standardly formatted either, unless you use like an API service to make sure that they're all formatted the same and whatnot. So you can see that the phone numbers would be harder to compare unless we clean those up. We're not going to do that for this example, but if you were to be doing this in practice in your company, you definitely want to make sure that your format for your phone numbers is the same. Okay, so going back down here, we now have the identity IDs. And yes, good point. The name and the email mismatches are sketch for sure. It is definitely unusual or a little confusing as to why A. Brown would be Christopher McBride or Keith Williams. That doesn't seem to make sense at all. Great point. Appreciate your participation. Okay, so here we are building out that graph. So this is what the graph would look like for the small example up in that we just looked at. So our nodes are the persons or identities, which we are representing with their entity IDs, the addresses, emails, the other attributes that are associated with the people. So the people nodes are the ones that are connected out to the attributes. So the attributes are not connected to each other. Edges only go from between people and their attributes. So you can kind of see how they connect together, and see how these, how you can see what kind of a component would be created based off of identities that are sharing different attributes. So how do we codify this? We codify this by taking all of the information we have and building it into these nodes and edges. I'm not going to spend a whole lot of time talking through this code. This is how you create the edges. You're going to make sure that you have your identity ID, your person as your source, your attribute as your destination. So you're connecting those two together. Identity nodes, of course, are being created for each of the different possible entities, the person, the address, the email, the phone number. So now I'm saying that we need to drop all the vertices with degree of 1. So you can see here that would only include in this specific subgraph the phone numbers. Ideas on how or why we basically why we would want to do that. Why are these vertices that only have a degree of 1 not actually important for what we're doing? It's Friday today. Is everybody eating lunch? Exactly. They're not suspicious. And it adds noise. Exactly. And they are a specific phone number. They're only connected to a single individual. They're not being shared. Exactly. Awesome. Thank you. Appreciate it. Great. So let's go ahead and drop those. So anything that only has a degree of 1 is going to be dropped, and the rest of them we're going to keep those. So we do that by actually using some built-in functions. So here we have the degrees, which gives us all of the different degrees of the different nodes for all of the different entities, phone numbers, etc. And okay, sorry. So we want to make sure that we aren't actually pulling out people, and we're only reducing down the actual attributes. So you can see that's done here. We're not actually pulling out people. And then in the next line, we make sure that we are keeping the people that are of degree 1. So as we continue down here, you can see with the address, you can see that it's degree 2, meaning it's shared with 2 different people. Here's another address that's actually being shared with 10 different people, making that far more suspicious. Unless you have a house with 10 different people living in it, it happens, but is less likely than 2 people living in a house together. So now what we want to do is construct a new graph using our new edges and our new nodes. So now that we've dropped the single attribute nodes and pulled them out as not being shared, thus not important, we're able to create a new graph. So our new graph, we want to really understand the different relationships between them. Looking at the degrees of the different nodes was helpful. But instead of having to try to join everything together using SQL, we're going to use an algorithm called connected components from the Graphframes. So basically, this is going to help pull out anything like those little subgraphs that are all connected together. So when we take a look at this, we can see here the connected components have run. We can see that there's an individual, and so for every individual, it's in a component. so that you can kind of see that they're all numbered. At the top here is just we've actually only having the results here, the components by people, looks like. And then when you come down here, you can actually look to see what the components look like more specifically. We're really not concerned about components with a single person in them, right? If there's one person and they're connected to lots of different attributes, we don't really care because they're only trying to be one person. So here we're going to only pull out components that have more than one person in them. So here's just kind of a quick peek at what that synthetic list of IDs might look like, or the potential synthetic IDs, and the different components that they're in. I like to continue to try to pull this back to our original example, just so it's a little bit easier to, I don't know, to think about, to picture in your mind. Works for me. So one of the identities we looked at, 4960, was Keith Williams, I believe. And so you can see the address, the person, and the email here. So we know we have two people and they both share these identities between them now. And so we can easily move forward looking at these different shared attributes. Now at this point, we can use just straight SQL to take a look at those. So here, we've kind of pulled together in a SQL table a little bit easier view of this. We now have the component ID, and you can see what person. So there's only people in the first ID column, and in the second ID column, you can see that there is the shared attribute, as well as any other person that they might be connected to. So now what do we do with that? We really need to be able to create some sort of score or ranking so that we can make sure that folks have their time dedicated correctly to maybe investigating shady IDs within, with an appropriate method, right? We want them to utilize their time as best possible. So here we're going to create a score, and this is basically by looking at how many different other components that there are, other attributes there can do. Higher score is a higher risk. So here you can see we have the score that's now connected to both the component ID as well as the person on the left. So we now are calculating the score for each different identity. And so you can see if you sort on this score, there's some with really high score and some with a lower score. 2, of course, is going to be far less concerning. That's actually what I would consider to be more like normal. I share a lot of information with the people who live in my house, address and whatnot. And I definitely use my boyfriend's phone number when I go to the grocery store so that they don't have my information. They just have his information. So if King Supers were to be looking at my identity and trying to decide if my boyfriend and I are actually the same person, they may conclude that, or at least conclude that we both live in the same house. Okay, next piece here. This is really just writing it out to Delta, saving it to our database. Okay, the next piece we're going to talk about is structuring. It's also called smurfing, but it's another common pattern when we're trying to discover any sort of money laundering. So now we are less focused on the people and a little bit more focused on the transactions. So here we were trying to understand the amount of money that's being sent and in what way. Becomes a little more clear as we move forward. So again, we want to build a graph, especially if you looking at the smurfing structuring graph here, you can see why it makes sense to use Graphframes for this. Oh, one other key piece is that money transferred under the amount of $10,000 doesn't get flagged. And so a lot of times that's why you start with smaller amounts of money before moving bigger amounts of money in the end. Okay, so here Nothing special. We're really just creating those edges and those nodes together so that we can use a graph frame. And then in order to really look for that specific graph structure, what we're going to do is use a technique called motif finding. So a motif is really just that subgraph structure that we're looking for. So here is an example of what we're going to look for. So we've got two individuals, A and D, that are depositing money to different banks, B and F. Those are then going to deposit money to C, and then C is going to send money to G. And of course, really what tracks or what tips it off is that money from C to G is actually more than $10,000. So we're going to come down here. You can see that we've used that motif and we're using the Graphframes algorithms to find that motif. And we can see what that looks like here. We have different identities on the left, the amount of money that's transferred between them, and to whom and how much. The amounts are smaller initially, and then towards the end, as we keep going, you can see that the amount is higher as we get towards the end of what's being sent from C to G. So when we originally looked for this motif, where's that? Oh, here it is. So when we're looking for that motif, we haven't actually specified anything in terms of dollar amounts. And this is a really small example. Whereas when we look at this original graph structure up higher, we can see here that there is essentially two of those graph structures put together. So that's actually what we're going to look for. And we're going to do that by joining our motifs. So we have our structure here. We know what that looks like. We're now going to join that where the final dollar amount between those in those last edges, if you put those together, is that amount above that $10,000 threshold. So after creating that joined set of motifs into graphs, we can now kind of pull those out. So in here, we've made sure that the actual entities that we're looking at are our companies, but you can see that here I'm looking at A, B, C, and G. So this is pulling in both sides of this original graph. So we're looking at both the ABCG as well as the DFCG when we're looking at pulling out those motifs and looking at them. This is really just so I can take a look at what those levels look like. So when we look at those, you can see the different names here. And so we can start to understand what level these different identities are playing at and the money going between them. It's a really good idea. From here, you can move forward with other types of analysis to see if there are regular folks that live at the level 0 or level 1 or the final level. Do we ever have where level 0 is the same as level 3, which would be looking like something more like round tripping? So we'll move down here to round tripping. So round tripping is very similar to the previous one. Essentially, it starts from somebody, it moves around, and ends up back where it started. We're going to do a very similar technique. We're going to be focusing on this, looking at a motif, using this to find it. The Graphframes algorithms already defined it. So you can take a look here at what this looks like. Very similar. It's just pulling out that substructure and making sure that we have the amounts on those edges to really understand what the dollar amounts are that are being passed around. So once we find that, we can now go through here and look at the different names again. So what are these different identities and where are they being sent to? And then you can sum up actually to understand the total money that's being sent after all the different pieces are being put together. And so here you can see that actually the dollar amount is the same for all of these. And there's there's only 4 rows as the specific answer. So we're saying that there are 4 rows that are being identified as round tripping. So that's those subgraphs. Any idea why there's only 4 and why they all share the same amount? So when we think about what the graph looked like for round tripping, specifically for the way that we did it here, we have A is going to B is going to C is going to D, and D is going to A. So we're actually creating a circle. Our round trip is less complicated than the one in the example here. It's a circle. And so if it's a circle and making it back to our original user, then we actually have 3 intermediaries, and a circle is going to be found for each version of the circle. So these are all actually the same subgraph. It's just the graph is starting at a different node or a different person. So that's why there's 4 of them. There are 4 different identities involved, and they all have the same amount that's being transferred around because it's the same subgraph. So what that means is we only are seeing round tripping once, which is fine. That's a good result anyway. Something to look into. Awesome. And last but not least, we have risk score propagation. So risk score propagation is actually kind of cool. It's more complicated in terms of graphs than the Graphframes library supports, but we actually have something called Pregel, which really is it's a little bit more complex, and it was kind of built for this purpose in the sense of seeing how a specific node in a graph can propagate out to its neighbors. So here we can see there's like the starting state. So we know 3 is a high risk for being bad or suspicious or committing crimes. And so then we do an iteration, and anybody that, that particular node 3 is sending money to also is considered to be dangerous. Not as dangerous, but it's something to consider. And so we propagate that out again to iteration 2. We're able to see further out. The further out we go from the network of the initial, high risk entity, we can see that the folks around them that are connected to them are also potentially dangerous. So we do as we do every time. We go ahead and we build that graph out, and then we're going to use the different pieces and put those together down here. So we are still using technically Graphframes because we're still building the graph using Graphframes, but Pregel is a specific piece of Graphframes. So you can see that we're actually iterating 3 times. We're iterating the risk score and pushing that out. Really kind of cool that you can do this so easily. Trying to do this using SQL would be very difficult. And then we're just going to take a look at that. So here we're just taking a specific look at an example here. You can see that each of these now have their own risk score. And so that'll be based off of how close they are to the originally identified individual. Okay, we covered a lot. I talked really fast for 42 minutes. I hope this was exciting and helpful and interesting. Most of us are not actually looking for money launderers, but we are looking for how do our customers connect? How do our our customers have different attributes and all of these different pieces in terms of really understanding networks, social networks. You can do this with following, with friends, with lots of different things. Graphframes and whatnot can be used in many different ways. So I hope you can find a way that you could use this at your own company, and that today was helpful. And feel free to check out the resources. I'll be sending them out with the recording. and have a great weekend. Thanks so much.